guys, we're doing lesson 10, the distributive property part 2. We only have one learning target today, and it is I can use a diagram of a split rectangle to write different expressions with variables representing its area. Okay, that was kind of a lot to unpack, but I think that what this learning target is telling you will make sense as we do the lesson. So, 10.1, possible areas. A rectangle has a width of 4 units and a length of m. I'm just going to draw a picture. So let's see. Okay, we have a width of 4 and a length of m. Write an expression for the area of this rectangle. Okay, so remember area is length times width. And so we're writing an expression, and it's going to be 4 times m or 4m. Both of those would be an appropriate expression to represent that. It's okay that you don't know what m is yet. Number 2 says, what is the area of the rectangle if m is 3, if m is 2.2, or if it's 1/5? So what you're going to need to do is now plug in those values for m. So 4 times 3, 4 times 2.2, and 4 times 1/5. Go ahead and pause this video. Try those on your own. Alright, hopefully you tried those and then you unpaused it. 4 times 3 is 12. Okay. 4 times 2.2 is 8.8. And 4 times 1/5 is 4/5. So these are what the values for the area would be if m were those values. Alright, number 3 says, could the area of this rectangle be 11 square units? Why or why not? So what that would be is that 4m, or 4 times m, equals 11. Is that possible? Take a second to think about it. Okay, you may have said no, because you may have been thinking 4 times something is not equal to 11. However, if you're thinking about fractions and decimals, it is completely possible. You could divide this side by 4 and this side by 4, and then you would get that m is equal to 11/4, or the decimal, let's see, 4 goes into 11 2 times, and it's 8. 11 minus 8 is 3. Add a decimal. 4 goes into 37 times. Okay, 2.75. So m could be 2.75, and that would make the area of the rectangle 11. Alrighty. I went through that pretty fast, so hopefully you were taking the time to pause the video and kind of think through it your own. But yeah, let's go ahead and move on. Here are 2 rectangles. The length and width of one rectangle are 8 and 5. The width of the other rectangle is 5, but the length is unknown, so we labeled it x. Write an expression for the sum of the area of the 2 rectangles. Okay, so the sum of the 2 rectangles means that we're adding these 2 rectangles' area together. So first of all, we can figure out that the area of this one is 8 times 5, which is equal to 40. And now we have 5 and x. So in order to find out what the area would be, we would have to do 5 times x. Okay? So an appropriate expression for this would be 5x plus 40. And remember, an expression does not have an equal sign, and so this is enough to be our answer. Okay, let's see. I'm going to flip the page. We already did this one, so just ignore it, and you can go back to the video if you still need it. Number 2 says the two rectangles can be composed into one larger rectangle as shown. What are the width and length of the new large rectangle? Okay. So this length is still going to be 5, okay? But now we have this width that goes all the way across. And so we can represent that by adding them together. So we can't really add them together, but we can write width as 8 plus x. All right? So our width is 8 plus x, and our length is 5. Number 3 says, write an expression for the total area of the large rectangle as the product of its width and its length. Okay, write an expression for the total area of the large rectangle as the product means multiply, of its length and its width. So remember, area is length times width. So we need to look at what our length is, which is 5. And now we need to look at our width, which is 8 plus x. And this is where it's important to think about the expression that we're writing, because if I do 5 times 8 plus x, we're not going to get the right answer. We're not going to be accurate about what our area is. So I want you guys to think back to yesterday's lesson with the different ways we can write things. And I want you to think about those notations. So the correct way to write this for this expression would be to use parentheses. Because what the parentheses do is they let you know that if you knew what x was, you have to do this first. In order to solve with the parentheses, we would have to distribute the 5 to both, and we would get 40 plus 5x, which is the same as this. And that's going to give us a different answer than if we were to do 5 times 8, which is 40 plus x, which would give us 40 plus x and not 40 plus 5x. So it's really important to use parentheses with stuff like this. Okay, I know I'm going through this lesson really fast, and I don't know why, but if you're stuck, please send me an email, and I can slow down and go through each problem with you at a slower pace. 10.3, area of partitioned rectangles. So what partitioned means is it just means split up. For each rectangle, write expressions for the length and width, and 2 expressions for the total area. Record them in the table, check your expressions in each row with your group, and discuss any disagreements. Okay, you don't have a group, so just try your best. Let's look at this first one, okay? So that one's going to go right here. I'm going to put an A there so we know which one it is. Now looking at this rectangle, the expression for that is going to be 3 times A. Okay, and then if you're looking at the rectangle next to it, you have 3 times 5. So you're adding together 3 times A plus 3 times 5. So now, recording in the table, your width was A plus 5, and your length was 3. Okay. and area as a product of width times length. So that's exactly what we were doing up here. We have 3 times A plus 3 times 5. So does this look familiar at all? Here we have the 3 for both, and we have the A and the 5. Okay, area as a sum of the areas of the smaller rectangles. Okay. Oh, you know what? I did this wrong. So that one should actually go right here. What should have gone in the one above it is we're taking our length, which is 3, and we're multiplying it by our width, which is A plus 5. Okay? Product means multiply. Sum means add. So that's why I messed that up. Okay, let's look at the second one, B. Okay, our length is 6 plus x, and our length is 1/3. Okay, so now it says it wants us to write it as a product of width times length. Okay, so we're gonna have 1/3 times 6 plus x. And I'm doing the one with the addition in the parentheses, okay? And then area of the sum of the rectangles of the smaller ones. So in order to solve this small rectangle and this small rectangle, we have to do 6 times 1/3 and 6 times x. So that's going to be 6 times 1/3 plus 6 times x. Okay, I'm going to do one more with you guys, and then I'm going to let you guys try the rest on your own. So if you're looking at C, we have a length of R and a width of 3, or 1 plus 1 plus 1. So we're going to put R plus, R is just going to go here. And then we're going to have 3 here, because 1 plus 1 plus 1 is 3. Area as a product of width times length. Okay, so that's just going to be 3R, or 3 times R, same thing. And then area as a sum of the area of the smaller rectangles. So we're going to have R times 1 plus R times 1 plus R times 1. Good. Okay guys, I really want you to try the next couple on your own. Please reach out if you need help, and I hope you got it, and if not, just let me know and we'll keep working.